Corre para atrás, papi, viste, te lo estoy diciendo, Dios mío.
Ay, pinga.
Ay, Dios mío.
Pero qué pinga.
Ay.
Vamos a ver.
Papi, cuidado.
Espérate.
Ay, Dios mío, señor.
Pinga,
Ay.
Cojones.
Mira la cantidad de gente cogiendo candela, papi.
No, pinga.
In a shocking turn of events, the National Transportation Safety Board, NTSB, has taken the lead in investigating a tragic UPS plane crash in Louisville, Kentucky, that occurred on a fateful morning in early November 2025. The first few seconds of the flight painted a picture of routine normalcy, but they quickly set the stage for a disaster no one could have predicted. It all started with a chilling sound, a repeating bell echoing through the cockpit just moments after takeoff, signaling the beginning of a desperate fight for survival. As the aircraft climbed into the sky, that haunting noise sliced through the calm, marking the start of the final 25 seconds of control. The pilots, caught off guard, scrambled to stabilize the jet as an unseen threat grew with terrifying speed. The stark difference between a seemingly perfect takeoff and this sudden alarm raises a burning question that pulls us deeper into this heartbreaking story. And hey, if you find this video gripping, drop a 1 in the comments below to let us know you're hooked. Let's rewind to the very beginning of that ill-fated flight. On the morning of November 5th, 2025, the skies over Louisville were crystal clear. The air was calm, and the runway conditions couldn't have been better for a standard cargo mission. The UPS MD-11, a heavy cargo jet, sat poised at the runway's edge as the crew methodically worked through their pre-flight checklists with laser focus. Recordings from the cockpit voice recorder, CVR, later revealed that every step was completed with precision, no hesitation, no red flags. The pilots chatted through their briefings in a relaxed, familiar rhythm, and nothing on the instrument panel hinted at any trouble. As the engines roared to life, the jet surged forward with the steady acceleration of a well-maintained machine, rolling down the runway just as expected. This initial phase of any flight is typically the most predictable, and the crew leaned on their training to call out each milestone with confidence. The takeoff speeds were announced in sequence, with both pilots agreeing that the climb felt rock solid. The aircraft lifted off with a smooth rotation, and the landing gear tucked away without a hitch. No odd vibrations, no cause for concern. The CVR captured no trace of worry in their voices as the jet continued its ascent, following the textbook path of a safe departure. These seemingly mundane details are crucial because they highlight one chilling fact. Nothing obvious warned the crew of the nightmare about to unfold. A clear sky, a pristine runway, and a seasoned team laid the groundwork for what should have been a routine flight to Hawaii. Add to that the pilot's extensive experience, thousands of combined flight hours, and it's easy to see why everyone felt confident. Cargo giants like UPS rely on rigorous training programs to prep their crews for grueling flights, and this team was no exception. The captain and first officer knew the MD-11 inside and out. Their tight coordination in the cockpit reflected years of flying together, a deep trust in the aircraft systems, and an unshakable grip on every phase of departure. The atmosphere was calm, their voices steady, making the sudden shift to chaos later in the flight all the more jarring. Skilled pilots rarely encounter emergencies this early in a flight, and the complete lack of warning signs only amplified the impact of what came next. The takeoff unfolded as planned, with no hints of confusion or mechanical strain on the CVR. Engineers later confirmed the jet hit the standard climb profile for that runway, and no external factors, like weather or air traffic, disrupted the ascent. Even the morning's weather briefings predicted stable conditions across the region. Everything lined up for a flawless start, which makes the investigators' shock at the ensuing tragedy all the more understandable. When a flight kicks off without a hint of tension, even the tiniest glitch can spiral into a catastrophe, shattering the rhythm pilots depend on. Fast forward to the critical moment, second 37 of the flight. That's when everything changed. The CVR picked up a sharp, repeating bell cutting through the normal hum of the MD-11's cockpit, a sound that told the crew something inside the aircraft had gone horribly wrong. A repeating bell isn't just a minor alert, it's often a sign of a system reacting to a dangerous, unexpected shift. Pilots are trained to treat it as a red alert, and this one hit without warning, forcing an instant response despite having almost no info on the cause. Amid the roar of the engines, that bell demanded attention, its relentless rhythm screaming for action. In the cockpit, stress levels skyrocketed as the crew had mere seconds to make life-or-death decisions while the jet started behaving unpredictably. The next 25 seconds of audio revealed just how fast an emergency can snowball. The pilots' voices shift from calm coordination to razor-sharp focus as they battle to steady a plane slipping out of control. The MD-11, a massive and powerful jet, is a beast to handle once it starts to falter. Regaining control demands perfect teamwork and split-second timing, something the crew fought for with every ounce of skill. The recorder captured their rapid adjustments to the controls, and though the exact trigger of the alarm remained a mystery, their immediate reaction showed they knew the stakes. They pushed and pulled, countering every shift they felt, their urgency palpable in every move. Still airborne but dangerously low, any loss of stability at this stage left them with almost no room to recover. The brevity of the recording drives home a grim reality. The crisis exploded faster than anyone could have anticipated, leaving the crew no time to fully grasp what they were up against. The NTSB later confirmed the plane crashed just 25 seconds after that first bell, a blink of an eye in aviation terms. That tight timeline explains why the pilots couldn't call for help or run through emergency checklists. Their focus was glued to the controls. Checklists are useless without time to diagnose the issue, and this flight never got that chance. The MD-11 was already descending as the alarm blared on, and the deadly mix of speed, weight, and low altitude made recovery nearly impossible. Even a slight imbalance in thrust or structure can trigger a domino effect in a heavy jet, and investigators used these final seconds to piece together how the disaster unfolded. The audio's last moments are haunting. The pilots' voices show no panic, just determination as they fought until the end. This rapid descent from normalcy to emergency begs a critical question. If the warning hit so suddenly, what mechanical failure could have caused such a swift loss of control? The investigation zeroed in on the left engine and its pylon, a structural component that became the key to unraveling this mystery. A pylon connects the engine to the wing, built to withstand massive forces during takeoff and climb. When investigators discovered that the entire unit, engine and pylon, had separated from the wing together, it shifted the case's focus. This ruled out early theories and pointed to a failure within the wing structure or an unexpected load shift. Such a break isn't supposed to happen. These parts are engineered for extreme stress, so the fact that the pylon stayed attached to the engine suggested a deeper, hidden flaw. The NTSB flagged this area as Priority 1, knowing that an engine detaching mid-flight almost always signals a catastrophic structural issue. They dug into the history of that engine and its systems, combing through past inspections and major repairs. Records showed the aircraft had undergone a heavy maintenance check in San Antonio just weeks before, on October 15, 2025. These checks are thorough, targeting metal fatigue, fasteners, and attachments with tools that detect invisible cracks or internal stress. Since the pylon itself didn't seem to fail first, investigators explored whether a concealed weakness in the wing fittings or supporting frames might have given way under takeoff forces. Even a minor shift in thrust can twist these connection points, turning a tiny flaw into a gaping failure as the jet accelerates. The team also studied load paths through the left wing to see how lift forces interacted with the structure during climb. Every scrap of evidence helped narrow down where this disaster might have ignited. Clues from the debris field added another layer. Specialists noted the engine and pylon landed together, showing impact marks from above, suggesting the separation happened at high speed while the plane pressed forward. Lab analysis of the broken surfaces, checking for heat marks, bending patterns, and stress lines, helped determine if the break was sudden or a result of gradual weakening. Early findings showed no long-term corrosion, steering the probe toward a sudden structural overload during takeoff. As debris was pieced together, each fragment built a timeline leading to that fatal separation. But a lingering question remained. If the engine broke away with its pylon intact, how low was the plane when the pilots lost their last shot at recovery? Altitude became a pivotal factor. Initial FAA ADS-B data, recorded at the time of the crash on November 5, 2025, showed the aircraft peaked at just 475 feet. Adjusted for ground level, that meant the jet was a mere 100 feet above the surface, dangerously low for a climbing cargo plane. At that height, there's no margin for error. Pilots rely on altitude as a safety buffer, and without it, even a minor glitch can spell doom. This sudden drop alarmed investigators, hinting the plane was in distress well before impact. The NTSB cross-checked this with the Flight Data Recorder, FDR, which logs hundreds of metrics like vertical speed and engine thrust to map the jet's exact movements. Early reports stressed the ADS-B figure as the most reliable at the time, though validation was ongoing. That drastic gap between an expected climb and the reported low altitude raised questions about when the descent began. At 100 feet, the crew had no space to regain stability. A heavy jet like the MD-11 needs height and time to recover from imbalances, especially after losing an engine or facing a structural shift. Such failures can cause sharp tilts or yaws worsened at low altitudes. The difference between recovery and crash might have been mere fractions of a second, and the CVR timeline confirmed the crisis unfolded at breakneck speed. This left the pilots juggling everything at once as the plane reacted unpredictably, with no guarantee even the best moves could save them. Investigators now faced another puzzle. Did the plane ever gain height after the first sign of trouble, or was it doomed from that bell onward? The crash site itself told a story of violence. On November 5, 2025, responders arrived to find torn metal, charred cargo, and shattered parts strewn across an industrial park in Louisville. Heat lingered long after the flames were doused, navigated the site cautiously, wary of hidden dangers like pressurized containers and fuel residue. The scale was staggering. Local authorities reported over 500 personnel involved in rescue and investigation efforts. FBI specialists worked alongside emergency crews to neutralize hazards, while heavy smoke drifted over nearby buildings damaged by flying debris. The mix of heat, toxic materials, and scattered metal forced a slow, methodical response, with constant reassessments for new risks. The site's layout, filled with warehouses and machinery, complicated things further. Investigators struggled to distinguish aircraft parts from pre-existing materials, slowing progress as they used thermal sensors and detectors to pinpoint fragments. Some areas were cleared repeatedly as shifting debris revealed hidden pieces, each needing careful documentation. The chaos underscored the impact's severity and hinted at a longer than expected investigation. Deeper layers of wreckage promised more clues about the forces that ripped the plane apart, but accessing them was no easy task in such a tangled mess. As the probe deepened, focus shifted to maintenance records and simulator tests. The MD-11's recent heavy check in San Antonio on October 15, 2025, came under scrutiny. These inspections hunt for structural fatigue and hidden flaws with advanced tools, so investigators needed to know if anything was missed. UPS provided an identical aircraft for comparison, while simulators recreated failure scenarios, showing how quickly a small issue could spiral. Engineers also reviewed service bulletins for patterns across MD-11s, probing if this crash tied to a broader design or maintenance flaw. Each document and test added to a clearer picture of what might have started before the plane even left the ground. This tragedy reveals how a single warning can ignite an unstoppable chain of failures. From the repeating bell to the falling engine and the fatally low altitude, every piece brought investigators closer to understanding how a complex aircraft reached its limit. So, what's the biggest takeaway from this chain of events? What lesson should aviation learn? We want to hear from you. Share your thoughts, like this video, and subscribe to MindGap for more in-depth investigations. And if this story hit hard, drop a 1 in the comments to show your support.